Hello and welcome to my presentation of Future of Electric Vehicles. My name is Ahmed Hamoud and I am a senior at Wayne State University majoring in electrical engineering. I currently work at ZFTRW and do most of my work surrounding electrical components for crash test safety as well as radio frequency. I also am enrolled in a class learning about the electrification of battery-powered vehicles and how they function. Today I will be discussing the future of electric vehicles and how it will soon be possible to drive across country without having to stop to charge. Throughout my presentation, I will talk about three main points: present-day electric vehicles, what's planned for the future, and the challenges that these innovations could face. Currently, most electric vehicles can travel between 100 and 250 miles on a single charge. This is all depending on make and model. But charging stations are still very limited and could be very distant throughout the country. This requires drivers to be strategic in their travel plans, but this problem could all go away with this upcoming technology. Over the last 2 years, Afridi, who is an assistant professor at University of Colorado, and his colleagues have developed a concept for wireless power transfer that transfers electrical energy through electric fields at very high frequencies. The ability to send large amounts of energy to in-motion platforms across great distances from low-cost charging plates could one day allow the technology to expand beyond small consumer electronics like cell phones and begin powering bigger things like automobiles. According to Afridi, on a highway, you could have one lane dedicated to charging known as the electric highway. This means a vehicle could simply travel in that lane when it needs an energy boost, and could also carry a smaller onboard battery as a result. This all reduces the overall cost of the vehicle. Afridi also wants to take advantage of a more directed nature of electric fields rather than magnetic fields that are more commonly used. Magnetic fields are easier to generate, but with electric fields, this innovation will substantially reduce the cost of the system. Replicating this capability for an automobile in motion is far more difficult, requiring significantly more power to be sent across a greater physical distance from the roadway to the vehicle. A car traveling at highway speeds would not linger on any single charging pad for more than a fraction of a second, so the pads would need to be placed every few meters to provide a continuous charge. To solve the in-motion problem, Afridi had to think differently about methodology. Charging a smartphone only requires 5 watts of power. A laptop might need somewhere around 100 watts, but an electric vehicle in motion requires tens of kilowatts of power. So in his laboratory, Afridi and his students set up metal plates parallel to one another separated by 12 centimeters. The two bottom plates represent the transmitting plates within the roadway, while the two top plates represent the receiving plates within the vehicle. When Afridi flips a switch, energy is transmitted from the bottom plates, and instantly the light bulbs above the top plates light up. Power is delivered with no wires needed. The device has steadily improved to the point where it can transmit kilowatts of power at megahertz scale frequencies. So all in all, what we know is present-day electric vehicles can only travel about 100 to 250 miles before needing another charge. A big issue is that these charge stations can be very distant. With the creation of an electric highway, electric vehicles may one day be able to recharge while driving down the highway, drawing wireless power directly from the plates installed in the road that would make it possible to drive hundreds if not thousands of miles without having to plug in. Replicating this capability for a car moving at such high speeds will be difficult though. In the near future, Afridi envisions the technology being adapted for warehouse use, with automated warehouse robots and forklifts, for example. Thank you.